So now we're going to look at the points on number 5. So for part A, I see that we get 1 point for the denominator of f prime and another point for getting all of f prime. So basically what this means is that if I did the first step of the derivative, but I forgot the chain rule, because this is really a denominator if you see how they wrote it, right? It's 1 over x squared is that negative 2 power. So if I had forgotten this numerator up here, I would have still gotten 1 point if I had gotten the denominator right. I just wouldn't have gotten any of the other points because I wouldn't have f prime right and I wouldn't have the answer right. So then to get, as long as I get f prime right, so if I get all this right, then now I've got 2 points already here, and then everything I do here doesn't matter unless I get 1 over square root 3. So as long as I get 1 over square root 3, I get the other point. But anything I do here, any mistake in here, costs me that last point for the answer. So 2 points for getting the derivative right, and 1 point for the answer. Notice they left theirs as 1 over square root 3. But square root 1 over 3 is equivalent. The only thing that you can't leave it as is just k squared equals 1 over 3. So if I do that, I haven't really solved for k. So I need to say square root of 1 over 3 or 1 over square root 3 or square root 3 over 3. They didn't make any note about k positive, so I think we didn't really have to do that, but it's nice to do. All right, and then for part B, we got 1 point for the partial fraction decomposition. So that means this. As long as we got this, that's our first point in the whole thing. So we have to get all of this work right. We have to have the right coefficients. You could have the 1/6 in the top. I think they do it that way. So this is what I was trying to avoid by pulling the 1/6 out. Although the other thing they do is keep the whole thing as a single integral instead of doing 2 separate integrals like I did. The same thing. I think it's a little cleaner to make it 2 separate integrals, but it is more writing to do 2 separate integrals. And so we got 1 point just for getting this part right. That was worth 1 point. Then it's 1 point for the antiderivatives. So that means I have to have this line right, everything right on that line. That's 1 point. And then everything here doesn't matter as long as I get the answer, which is 1 point. So for the answer, I can have this big, long schloofty-glop, or I can just take this. Either way, I get that 1 point for the answer. And then for part C, all right, so I get 1 point for improper integral. So I'm not sure exactly what that means, but I think that just means recognize that it's an improper integral. So break it up and do some limits. You can, if you did this integral and you didn't know it was improper, and you just did an antiderivative and plugged in the 2 and the 0, you would get an answer. You would get the answer -2. So it's possible that what they're saying here is that if you did that, if you didn't break it up and you just did the antiderivative straight, you would still get the point for the antiderivative. You just wouldn't get anything else. So I could still get 1 point, I think, if I'm reading that correctly, if I had just ignored the fact that there's a big asymptote there and just did my antiderivative, I would get -2 for an answer. All right, so that's one thing. And I get 1 point for the antiderivative. So the antiderivatives are, I guess they just mean this. This is the antiderivative in here. Okay, so I get 1 point for recognizing that it's improper and splitting it up into a couple of limits. I get 1 point just for getting the antiderivative right, and then 1 point with the answer for the answer with reason. So the only reason that they give is that the first of their 2 limits does not exist. They say because limit as b approaches 1 from the left of -1 over b minus 1 does not exist, the integral diverges. So I take a little bit of issue because the limit does exist, it just happens to be infinity. But it's fine if you write it like this, the integral diverges. But that's the only reason they've stated, is because one of the limits doesn't exist, isn't correct. Isn't a finite number, isn't a real number. Right. Now we've given 2 reasons because neither one of those limits is a real number. But yeah, you actually only need 1. And one of the things I was going to suggest as a strategy is as soon as we get here and we say, oh, this limit does not exist, or this limit is not a real number, we can just stop the whole process right there and then jump to, since this limit is infinity, the integral diverges. So we could sort of save some work there, but I think it doesn't cost you too much to write this out. So there you go. Our answer with reason was 3 points. So this one was just straight 3, 3, and 3, kind of rare a little bit that way. But it kind of makes sense for the amount of work that is required in each part.